Hello and welcome. In this tutorial video, I will demonstrate how you can use data stratification for the creation of EDA displays in the KIWI Explorer module. KIWI Explorer provides stratification functionality in most plot and table EDA categories. In this video, I will define and illustrate the use of various kinds of stratification for plots and tables. For plot categories, I will illustrate the use of Interpage, Intra-page, and Intra-panel stratification. These three different stratification methods can be referred to using nicknames like paging, paneling, and grouping, and you will probably hear me use those terms during this tutorial. For table, I will illustrate the use of Intra-table and Intra-table stratifications. Finally, to conclude this presentation, I will demonstrate the use of some advanced stratification options. I will now switch to the application. KIWI Explorer was opened for a single dataset called edademo.csv, and the page is shown side by side to the profile manager open for the same dataset. I'm going to illustrate the different types of stratification using various examples of scatter plots, bar chart, and box plot. All the concepts that I will illustrate would apply pretty similarly across all the EDA types. We'll also talk about the stratification for tables, which is slightly different. I will start by talking about the Interpage stratification, or the concept of paging. Interpage stratification will result in the breakdown of the data into multiple subfolders specific to the variables that you've defined as the Interpage stratification strategy. In this case, I have a single variable used for Interpage stratification by study. So you will see a first panel dedicated to the study equal 1, another folder and an associated panel for study equal 2, and finally panel specific to study equal 3. To implement this Interpage stratification, you need to go to the profile configuration and select the stratification panel. I'm going to accept the rerun. To enter one or more variables defining the Interpage stratification, you need to go inside the Stratification tab and type a variable under the Stratification Variables field. This is a field where you can enter one or more variables, so you can keep on selecting variables. Typically, you can select between 1 and 2. After that, your data can start to become the number of data points by stratum will become extremely small and might not be a smart thing to do. So I selected the study variable and obtained that stratification. The default of the global profile would be to have no stratification, and this field would be empty. I'm going to close this page. You can use one or more stratification variables. In this case, I've used 2 stratification variables, dose and study. And in this case, the data is broken down by dose, by study and dose. So here I have study 1 dose 10, study 1 dose 20, and so on. So Interpage page stratification or paging is going to create subfolders inside your profile folder. You will not get an overall plot that would disregard this stratification. The second type of stratification is the intra-page stratification, or the concept of paneling. In this case, I've used one variable, the dose variable, to break down the data into multiple dose-specific groups. Each of those groups are shown in specific panels within a single page of plot. So this blue frame is associated with a single image file, and you can control the number of panels that you're displaying within a page. If you have more panels to create than is allowed by this number of page, you actually obtain multiple page of plots. So here I have a first image with the first 4 levels of my dose variable, and another one with the next 4 dose levels. To implement paneling or intra-page stratification, you also need to go to the stratification panel, and this time you need to go to the conditioning tab. Conditioning is the term that is used in the R world to define the paneling. In this tab, you can define one or more variables to use for conditioning, and you can also provide some text that will be displayed on the left side of the variable values. In this case, I've used the dose, D-O-S-E, but I could leave this field empty, and in which case only the value of the variables would be displayed. So I would see 10, 20, 40, 80. You can add a variable using the add button, and that will just show an additional row, and you can select a variable here. And as I said, if I leave the strip text here blank, no text would be displayed before the value of the day variable. You can delete any row by selecting the row of interest and clicking on the delete button. You confirm, and now the row disappears. So looking at the next profile, in this profile I've used 2 variables, study and dose. So here I have even more panels specific to a single study and a single dose combination. And again, this is done by going to the stratification panel and providing, oops, it's the wrong profile. Stratification, then the conditioning tab, and here I define the study and then the dose as my conditioning variables. To control the number of panels per page, you need to go to the layout panel, and the first field, number of plots per page, define the number of panels that will be included in an image file. In my case 4. You can select any value between 1 and 8. If you define number of plot per page to 8, I believe you would see you would use the entire space in a letter size, so a vertical or portrait layout. Here it's more a landscape layout with a 4 plot per page. Another option that you can control is how the strip is displayed. The default is when you have multiple conditioning variables, the default is to show the values separated by a comma, so they're shown on the same line and the values are separated by a comma. Sometimes the value could be extremely large, and they could the text could be larger than the actual available space in the strip. In this case, you may want to display each the information relative to each value on a separate line, and for that you need to go to the advanced setting and set the last field, multi-line strip, to true. So the default is false, so all the strip information is shown on a single line. Turning that to true will display this information on multiple lines. So that's it for the paneling. The basic paneling. There's some advanced paneling functionality that I will describe at the end of this presentation. For now, I would like to talk about the intra-panel stratification, or the concept of grouping. Grouping is essentially the display of the information within a panel using different symbols. That's the typical definition of grouping. To achieve this design, I need to go to this profile, and again you need to go to the stratification panel. To define a grouping strategy, you must go to this stratification panel and select a single grouping variable. You cannot select more than one here. So in my case, I selected the dose variable as my grouping variable, and I obtained different different symbols for each of the group values. You can combine all three types of stratification: interpage, intra-page, and intra-panel stratification. Why I mention that is because if you have some dose levels, in this case the grouping variable levels, which are present in one level of your stratification but not others, the symbol shown on one panel would be consistent. Sorry, not one panel, but one folder will be consistent across all the folders. So the red symbol will also will always dictate or designate the 40 probably milligram level in all your folders, even though it would not be available, for example, in study 2. The scatterplot, histogram, and boxplot profiles use the same set of colors and symbols to designate the different groups of the grouping variable. Bar charts use a slightly different color scheme. I'm going to illustrate here the use of grouping variable for a bar chart. So a slightly different set of colors are used for bar charts. Note that the pairwise plot matrix does not provide stratification functionality. I'm now going to switch to stratification for tables. Two types of stratifications are implemented. Here I'm illustrating both types. You can stratify the statistics within a table by defining one or more variables. Here I only define the dose as my stratification variables within a table. You can also break the data into different tables. And in this case, I broke the data by study. So you get a table for study 1 and all the different dose groups, another table for study 2 and all the different dose groups in this study, the same for dose 3. At the top, an overall table ignoring the stratification by study is provided. To implement this stratification, you need to go to the summary statistics profile and select the stratification panel. It looks quite similar to the stratification panel for plot categories. The tabs are slightly different. First, we have a page by, or sorry, a table by, which is actually the equivalent of the page by for plots. And here you can enter a single or multiple variables in this field. The stratification tab will allow you to define the variables that will control the intra-panel stratification. So in my case, I had dose. This is the equivalent of conditioning for plots. So we have the same design with the ability to define one or more variables. Using the add button, you can insert additional rows. The header text column will allow you to define a text that will be shown on the left side of the dose value, or whatever is your stratification variable in this case. And as I said, you could add as many stratification as you want. If you use multiple stratification variables, like I have done in this other stratification table profile, in this profile I have used the study and the dose as two variables for stratification. So when you use multiple variables, the design of the header is a little bit more complex. The headers are separated into multiple rows, one for each stratification variable, and the header relative to the first stratification variable straddle multiple columns relative to the second stratification variable. So you can see that in study 1 I had 1, 2, 3, 4, 5, 6, 7, 8 dose levels. I only had 4 for study 2 and only 1 for study 3. Before concluding this presentation, I would like to illustrate a couple of advanced stratification options, including some which are specific to the scatterplot EDA categories. I will click on this particular profile. So in this profile you can see different panels that are specific to a dose and a group, and the group correspond to actually a set of user ID. This set is different in the second group. You can see a different set of numbers. In the first panel for dose 20, you can see another group 1, which is associated with a different set of subjects compared to the group 1 in the dose 10 panel. You can also see that the same symbols are used for different subjects. The idea here is that we want to investigate the distribution of, let's say, concentration versus time for different subjects. But because there are so many subjects per dose groups, we want to break down that information into different panels, each panel is including 4 different subjects or up to 4 different subjects. So to do that, you need to go to the stratification panel. You want to use ID, so the subject identifier, to define your grouping variable. So that will tell KIWI to use a different symbols for each subject. And to obtain this particular design, you need to go to the advanced setting, and you need to set the first field, show data in bins of grouping variable. You need to set this field to true. In the global profile and in the all the other profiles that I've shown in this tutorial, this field was set to the default false value. Then you also need to define a number of grouping variable levels per bin. So in our case, how many subjects do you want to include in a bin or in a panel? So in my case, I used 4. Going to a number greater than 4, maybe something between 4 and 8 is still acceptable. Beyond that, it's probably going to be a little bit messy and busy in terms of what you can read. So this allows you to break that data by groups of grouping variable levels. Another advanced stratification option is specific to the scatter plot category and relates to the creation of spaghetti plots. Spaghetti plots are typically line plots which represent the profile of concentration versus time for each subject using individual lines. Lines are not necessarily distinguished using colors or line type by subject. And here I'm illustrating the bad way of creating line plots. The bad way result in these artifact lines that connect the end of the profile to the beginning of another profile. So the bad way to do that is to think that you only need to set the stratification, the type of plot to a line plot, and to assume that KIWI will just recognize that there are different IDs and it will break the data into different lines. No, KIWI will not recognize the existence of different ID because you did not told him to do so. It will just process the data in the order it is defined, and when it arrives at the end of the profile of the first subject, it will connect this end of profile to the beginning of the profile of the next subject, and so on. So to create a spaghetti the right way, like it is illustrated here, you need to not only define the plot type to line plot, but you need also to use stratification. And you need first to define the ID variable as a grouping variable, but you need also to tell KIWI to not use a different symbol for each grouping level, so setting this third row to false. That essentially tells KIWI to recognize ID or the different levels of ID as a different group, but it will keep on reusing the same black line design for each of those groups. The final piece of advanced functionality is not specific to scatterplot, but is shared across all the plot types. I'm going to illustrate that. When you're using grouping or paneling functionality, you can ask KIWI to create additional plots that ignore your conditioning and or your grouping variables. So here I have a set of box plots that were stratify, paneled by a study variable and grouped by gender. And so I have a panel for our plot for study 1, a plot for study 2, and a plot for study 3. And I've used this advanced functionality to create two additional panels, one that ignore the paneling by study. So I'm grouping all the studies into this panel, but I'm not ignoring the gender. And another panel is created that would ignore both the gender and the study stratification. So the way to achieve that, not necessarily that design, but the way to request those additional combined panel is also to go to the stratification panel, go to the advanced setting tab, and set the plot combining conditioning variables to true. Typically the default is true, but this would only apply when you have conditioning and or grouping variables. So this concludes our introduction to the stratification functionality in KIWI Explorer. Thank you very much.